Welcome to the second lesson of Excel tutorials. In today's lesson, we will learn how to generate equations, how to plot the equations on a scatter graph, and finally, we will learn to generate trend lines from the equations. So let us begin. We will start by generating a linear equation and then polynomial equation of a second order, third order, and so on. So if we first generate an equation, we first have x values. In column B, we write a random equation such as y equals to 5x minus 10. In column C, we will generate a second order equation such as y equals to x squared minus 5x plus 6. In column D, we will generate an equation of the third order such as y equals to x to the power 4 minus 10x to the power 3 plus 2x minus 8. So we have a linear equation, a second order equation, and an equation of the fourth order. Now if we want to draw the scatter curve of each of the equations, we need to generate different values. So let us generate different values of x of sec2 increment 2, 4. If we tell Excel to autofill the rest of the boxes, it will generate a values at 2 interval. So we generate up to 26. Now in order to fill in the boxes for the equation y equal to 5x minus 10, we type an equation. In the formula bar we write equals 5 multiplied by x. Where are the x values? Cell A2 minus 10, and we press enter. As you can see, 5 into 2 minus 10 is a 0. If we tell Excel to fill in the rest of the boxes, it will autofill. So we have our values. Next, for the equation y equals to x squared minus 5x plus 6, we type equals x, which is in A2, square minus 5 into x plus 6. And once again, this value is a 0. 2 squares of 4 minus 10 plus 6. If we join the rest of the boxes, we get different values of y. Finally, for y equals to x to the power 4 minus 10x cubed plus 2x minus 8, we type equals x to the power 4, that is a2 to the power 4 minus 10 into a2 to the power 3 plus 2 into a2 minus 8. The answer is 68. If we continue, what we see is the values first decrease and then they start to increase sharply. So we have different values of x and different values of y. Now we will plot the curves for these values. So in order to generate a curve, we need to select the values first. So we first select the values of x. In order to select a separate column, we hold the control button on our keyboard, we click and drag down the rest of the cells. So while we have our column A and B selected, we will generate the curves. So we go to Insert, Charts, Scatter Chart, and we select the scatter. As you can see, it has generated a linear curve for different values of x on the x-axis and y on the y-axis, starting from 2 up to 26. Now, this is a curve and we can generate different chart elements. In order to add more chart elements, we click on the green plus sign. And as you can see, we can add axis titles. So on the y-axis, we can write y equals to 5x minus 10. On the x-axis, we can simply type x. Now, we want to generate a trend line. So we want to join all these plots with a trend line. In order to do so, we don't click the trend line right here. Rather, we click on More Options. Now, if we can see, more options on the trend line have been generated over here. So let's take a closer look. If we double click the trend line, the Format Trend Line options appears. We select Trend Line options. The trend line that has been generated is a linear trend line. If we want to display its equation, we have to simply click on Display Equation on Chart, and it will show us the equation of this line. There are various options. A logarithmic curve. If we want to join the lines with a logarithmic curve, it generates a logarithmic trend line, which goes of the equation 42.01 for ln x minus 56.75. However, since our trend line is a linear equation, we select a linear trend line. Now, in order to generate another chart for the second order equation, we once again select the values of x and we hold the control button, go back to the third column, and we select the values. In order to generate the trend chart for this, we go to Insert, Charts, Scatter Chart, and we have a plot. Now, for this chart, if we want to generate another trend line, so we select the plus button, Chart Elements, and we select Trend Line, click on More Options. Since this is no longer a linear equation, rather it is a second order equation, we have to select a second order trend line. So we double click on the trend line, go to Format Trend Line options, and we select a polynomial curve of the order 2. If we want to display the equation on the chart, the equation is x squared minus 5x plus 6. As you can see, it perfectly joins all the plots. However, if we select a linear curve, the linear line does not cross all the plots, rather it is a best fit curve, as it covers the least distances from all the points. So we select a polynomial curve of the second order to satisfy this equation. Now, our third equation has x to the power 4 minus 10x cubed plus 2x minus 8. So in order to generate another chart, we select the data, go to Insert, Charts, Scatter Chart, and we select the scatter. It has automatically generated another curve. Now we need to add a trend line. So we go to Chart Elements, Trend Line, More Options. Now this time our curve is a 4-order equation, so a linear trend line cannot satisfy it. So if we go to trendline options, we select polynomial, so we can see an order 2 curve cannot satisfy it yet. This is also not sufficient. So we select a curve of order 4. As you can see, it perfectly intersects all the points. If we want to generate the equation on the chart, here we can see the equation is x to the power 4 minus 10x cubed. This is a value that is negligible as it is near 0, plus 2x minus 8. This is how we can generate different charts. Now, if we want to generate a chart for random values, let's try it. Let us input random values of x over here and random values of y over here, 10, 20, and so on. For different values of y, let's begin with 50, 140, 280, 360, 1000, 1220, 1550. As you can see, the values sharply increase and they start decreasing again. To avoid distraction, let's get rid of these charts. Now, if we want to generate a curve for these values, we simply select them, go to Insert, and we select a scatter chart. The scatter chart generated here shows us the different plots of x and corresponding y values. Now, if we want to observe the trend line for this, we have to add the trend lines first. So we go to add more chart elements and we select a trend line, and here we select more options. Now, as you can see, at first a linear trend line has been generated. However, this linear trend line does not give us adequate information on how this chart is behaving, how the data trends are. So we can experiment with different sorts of curves. We can select an exponential curve. An exponential curve rises upwards. However, our data is not an upward rising curve, is it? So an exponential curve is not sufficient. We can also choose to display the equations on the chart for more information. So we can select a logarithmic curve. A logarithmic curve also increases with increasing values of y. However, it too cannot adequately satisfy our curve. So we select a polynomial curve. A polynomial curve of the order 2 pretty much satisfies our trend. This is a best fit curve of the second order. And if you take a look at the equation, it is a second order equation, 0.3079x squared plus 54x minus 862. If we select a polynomial equation of the order 3, a third order equation has the ability to diverge and converge. So it is seen to change smoothly with changing values of y. If we choose to select a higher order equation, the plots only get more accurate, and as you can see from the equation, it also gets more accurate. So we can choose to increase the order of our trend line if we want to. And by changing the order of a trend line, we can understand how it changes, how more closer it gets to the actual curve itself. We can also choose the final option, which is a power curve. A power curve, as you can see, is where we have a coefficient with x to the power a certain number. This, however, does not give us true information. So we will select polynomial curve and increase the order until we get a satisfactory equation that models our data. If we want to, we can also display the r squared value, which is 0.9885 for order 6. For order 3 equations and second order equations, the r value decreases, which means the regression analysis shows a very poor curve. With a linear equation, the r squared value is 0.4895. A lower r squared values show us a very bad trend. So to accurately depict the accuracy of a plot, we have to increase the order until we get a satisfactory r squared regression analysis. That is the end of lesson 2.